Uh, okay, hello everyone, and welcome back to my YouTube channel. And as you must be aware, we are running a series of videos related with DC transmission systems. And today the session is dedicated basically to some numerical examples of calculations in DC systems. Okay, this is example 1.1, and this is a bridge rectifier, and we are talking about this is a current source converter, also known as line commutated converter. Okay. Here you can see the statement. We are considering a bridge connector rectifier, and in this case we are using a step down transformer, and this step down transformer is going from 230 kV to 120. Okay, and from a line that is coming from 230 kV, line to line RMS AC supply. Okay, now the question is, what is the DC voltage output when the commutation angle gamma is equal to 15 degrees, and taking in account three different scenarios for the delay or the firing angle. Okay, we are considering alpha 0, and then we have here the case of alpha 30 degrees, and also we have over here alpha 60 degree. Okay, and this is a very basic problem. Okay, because during my classes I already explained, okay, what is the equation that we need to use for calculating the DC voltage output. Okay, and for a bridge connected rectifier, okay, depending of the commutation angle and the delay angle, we have this formula over here, where V sub zero is basically a function of the line-to-line RMS AC voltage. Okay, here we have this beautiful constant, 3 times square root 2 divided by pi, and this is again the line-to-line RMS. Okay, if we have a supply on the high voltage, the supply is 230 kV. Of course, in the step-down transformer, we have a voltage that is 120 kV line to line. Okay, and over there, what we need to do is take that number in consideration. Okay. And the next step is extremely simple. The next step is, okay, you must be familiar what we are doing here, okay? What we are doing here is this equation over here, V sub D is equivalent to the output voltage, the DC output voltage over here, okay? And as you must remember, changing the angle alpha, changing the angle alpha, um, alpha and alpha and gamma, they are defining how the commutator is rectified and the DC voltage that we can get from this bridge. Okay, and now it's extremely simple. It's just question of substitution. Okay. Um, if you look over here, I have the same expression, is 135, that is the constant that I was talking about, 1.35 multiplying the 120 kV line to line on the low voltage side of the transformer, divide by 2, cosine of alpha, and in this case we have alpha equals 0, and gamma equal 15, and as consequence in this sum over here we have 15 degrees. Okay, as you can see over here, we can reach a high voltage 159.2 kV, and that is the DC voltage that we can get in the rectifier bridge if alpha is equal 0. What's happening if we increase a bit more the firing angle? If we go for 30 degrees, as you can see, if we go for a bigger angle, this section over here start to go deeper down, and as consequence, the average value that we will get, or the DC voltage that we will get, is a bit smaller, okay? In this case, the alpha is 30 degree. You can see over here, cosine of 30 plus cosine of 15 plus 30, that is cosine of 45 degree, and as consequence, the final voltage is 127 kV, okay? If we go further, as you can see over here, if alpha is 60 degree and gamma 15 degree, well, if we use again the same equation, but considering alpha 60 degree, we get 69.2 kV, okay? What is the main conclusion over here? Well, if we change the angle, as a consequence, the DC voltage is changing because we are working on rectification. Okay? Okay, no problem. Well, this is all for this very basic example. I hope you enjoy. It's very simple. It's just understanding the basic concept of rectifier, of this bridge rectifier. Okay? Thank you very much for watching this video. See you very soon in the next one. Thank you.